Science, scientific, scientifically proven. These terms are thrown around everywhere in today's society. But what do these terms truly mean? What is science? Science in one form or another has existed for millennia, dating back to the earliest days of human civilization itself. However, for the modern definition of science, we must go back 400 years to understand what science truly means to one Sir Kevin Bacon and how it has taken us from a medieval society to the one that we live in today. The journey of 400 years, multiple key individuals, hundreds of papers, books, millions of words, countless proven and disproven theories, and all our attempts to explain the very world we live in all begin in the very same place, at the very heart of science. What lies at the core of this world is one simple idea that defines modern science as we know it: the scientific method. There are a few main steps to this method that outline the basis of every science that exists, whether it be natural or social. These steps are observation, making a question, creating a hypothesis, designing an experiment to test the hypothesis, experimentation, analyzing the results, and drawing conclusions. And finally, the most important, to iterate by using those results to make new predictions or hypotheses. On the surface, you may think this is an overcomplicated description of things we do on an everyday basis. I mean, how we learn so much about the world from nothing can be described in the very same process, just simpler. However, this is why I said that science has existed in some form or another since the day human civilization began. The rigor of this scientific method, however, is what lies at the heart of modern sciences as we know it. The very first step is observing the world. The true importance of science is to learn about the world around us, and that starts with observation. Whether it be Newton having noticed a falling apple, or Galileo having noticed the phases of Venus and Jupiter's moons, or whether it be Darwin's observation of species, all scientific thoughts start with the observation of the real world. It could even be a simple thought, such as Einstein's thought about a man falling off a building, or Mendeleev's dream about the periodic table. Whatever the case, that observation or thought is where the scientific method begins. The next step is asking a question. The question can be anything about your observation: the what, why, how, when, etc. When Newton saw the apple fall, he asked why the apple fell. When Mendeleev imagined his periodic table, he asked what the true periodic table would be. When Darwin noticed species, he asked how they came to be so diverse. This curiosity and the ability to ask a question rather than just accept something as fact is what truly drives science. However, that curiosity exists in every field, and what separates science is the most crucial next step. The next step is the hypothesis. Theology was another field of study that dealt with asking questions about the world. However, what separated science during its infancy was the idea of a hypothesis. A hypothesis is a testable prediction about the world, which may or may not be correct, and it defined science as we came to know it. That is why science deals in hypotheses and theories. We can never be sure in science, and we must continue to question whatever we know and whether it's right and what more we can learn. However, now that we have a hypothesis, we must test it. This is where we design an experiment. Experiments are what you may remember most about science from school. However, experimentation is the only method we have to truly learn about the world. We are not omniscient beings, and no matter how elegant our theories are, they carry no precedence until they are vigorously tested by experimentation. For any good experiment, there must be an independent variable that is changed and a dependent variable which is measured. Every other variable has to be controlled, and as such, they are called control variables. Once the experiment is done, we must analyze the results and draw conclusions. We must see if our hypothesis was right or wrong, and the reasons for why that might be the case. We must also consider sources of errors. Perhaps the control variables were not well accounted for, or there were errors in the experimental design. We must also draw mathematical relationships and derive physical constants, as the world deals in mathematics. However, we are now missing the part of the scientific method that keeps science toiling. This last step is what drives the engine of modern science. It is iteration. This is why we ask more questions. If our hypothesis was incorrect, why is that so? What is a better explanation? We can make a new hypothesis and test it. If the hypothesis were correct, We can still ask, why is that the case? Are there any deeper relationships? We can ask all sorts of questions in this step, and then we continue with another hypothesis, another experiment, new conclusions, and continued iteration. That is what has kept the engine of science toiling for years and gotten us from here to today's modern society of scientific understanding. This scientific method has taken us to places we cannot imagine and will take us to many more places we cannot yet comprehend. Thus, to answer the thesis of the video, the scientific method, that is science.